The next session, I think, is more professional. This is more professional to .NET developer because it talk about intermediate language. I will introduce the speaker to join the platform. Fidiano. Oh, hi, Fidiano. Hello. I think the time is running. I will give you some share the screen now.
Thank you. Well, hello everybody. My name is Ferdinando Papale, and I am a .NET developer at MongoDB in Copenhagen, Denmark. And the reason why I'm here is that I would like to tell you a little bit about why we decided to move from using IL weaving to third generator in the .NET SDK of Realm. So if you haven't heard about Realm before, Realm is an object-oriented database that is mostly targeting mobile, but I will tell you more about it later. So just to set up the context, so what I'm going to talk today is mostly code generation in .NET. This is because both IL weaving and third generators are two different techniques that can be used for code generation in .NET. They do it in very different ways, I will see, and they have both, let's say, pros and cons. And then we have to see how these are actually used in the .NET SDK of Realm and why we decided to move from one approach to the other one. So before going to the main part of the, let's say, of the talk, I want to first introduce what is IL weaving, and then we'll see what is third generation. So first of all, what is IL? So every time you compile .NET code, this gets compiled to something called IL, that stands for intermediate language. And then depending on your configuration, if you're using just-in-time compilation, so JIT, then the code gets compiled, that's converted to machine code at runtime. Otherwise, it gets compiled, converted to machine code ahead of time if you're using AOT. So in general, anyway, you always have this intermediate step with IL, with intermediate language, that it looks very much like high-level assembly, and it's similar to Java bytecode, if you have experience with that. So we will see it in a moment how it looks like, just to have an idea. But the important thing is that IL weaving essentially is the process of modifying the IL code in any way. And it almost feels like magic because you can modify methods, modify attributes, interfaces, and almost anything. The important thing that you need to remember about IL weaving is the fact that this process happens after the compilation is done. So the code already needs to be compilable in order for the weaving to happen. And now you'll be wondering, okay, why would you want to use a library that is using IL weaving? Because it's very useful to generate repetitive or optimized code. So just to give an example, if you have, for example, this simple person class that you see on the left with the name property that has a getter and setter, this is what you will write normally in your IDE. And on the right, you can see the IL code that is obtained after compilation. So on the top, you can see the getter, and at the bottom, you can see the setter. It's not really important what is happening here, but it's just to give you an idea about the fact that it's not really easy to understand what is actually happening with IL code. So maybe now to give you a more concrete example of a library that is using IL weaving, if you ever worked with any framework that uses MVVM, like for example Xamarin, Maui, Avalon, and so on, then you know that in order to bind something to the UI, you need to have iNotify property change implemented into your model and view model classes. So as you can see on the left, essentially the only thing that is present in this interface, in the iNotify property change interface, is one event, this property change event. And the contract between the class that is providing, that is implementing this interface, and the listener to this event is that this event should be raised every time one of the properties inside the object change. So if you had to do it manually, what you will need to do is that you will need to convert what you have on the left to what you have on the right. So practically what is happening here is that you have to change all the setters and getters. So when the value of any property changes, you are raising this property change event. This process, as you can imagine, it's quite annoying to do because it's very repetitive, and it can also be error prone, for example, if you have dependent properties. So if you have, for example, a full name property and that depends on two other, on the first name and surname property. So what property change authority is doing essentially is implementing this for you. So you just write your code as you will do normally, like you do on the left. And then during weaving, the library is essentially finding the classes that are declared as implementing this interface, and then is modifying the IL code to create to raise the property change event. One important thing to remember here is the fact that so you as a developer, you write what is written on the left, and you will still be able only to see that. What you have on the right is how the code acts, but you will not be able to see that, at least not from your IDE. So this library is very useful when you are when you have to implement this interface. Even though now there is also actually a search generator alternative to this. Now, as I said before, actually, you are not able to see IL code directly, but we have some possibilities if you want to see IL code or with code. So if you're just curious about how is the IL code corresponding to some simple code that you want to write, you can use something like SharpLab, that is an online .NET playground where you can just write your code, you can run it, and you can also see the IL code. If you want to see instead how is the weaved code or the IL code corresponding to one of your projects, for example, a bigger one, then you can use something like ILSpy or other decompilers that will show you what happened to your code after compilation. Okay, so I presented the IL weaving. Now you have to take a look at search generators. So search generator are a compiler feature that was introduced with .NET 5, and they're essentially part of the compilation pipeline. So when there is a search generator, one or more in your code, what happens is that the compilation goes in the way that is shown in this schema on the slide. So practically there is the first step of the compilation, and then there is the search generator step of the compilation. In this step, practically the compiler creates the search generator pass something called a compilation object that they can analyze. So practically with this, the search generator can analyze everything that the user wrote, and then eventually, starting from this, they can generate new code. This new code is then added to the compilation, and then the compilation resumes. So essentially, search generators can emit source code, and they're only additive. They can only add source code. They cannot modify code that is already there. And this is one of the two main differences with IL weaving, because IL weaving can modify everything, while search generators can only add new code. And the other difference is that search generators, the search generation part essentially happens during compilation. And so, for example, you can implement certain things so that the search generator, the code could be not compilable before the search generator, but then it could be compilable after the search generator generates some code. So it's different from IL weaving. And why would you want to use search generators? Well, because most of the time they're also very useful to generate repetitive or optimized code. For example, to talk about the library that maybe you have used, there is system.text.json. That is a library that is used to serialize and deserialize JSON, as you could imagine from the name. And the way that this was introduced I think 2 years ago with .NET 6. And the way that you use it is that you define your class, like you see here on the left, on the top part. you define your class with your properties, and then in some other parts of your code, you need to define a JSON context, like you see on the bottom left, that is deriving from this JSON serializer context and then you need to put an attribute with the type of the classes that you're interested to. Then it's not very important. That's actually what is happening here. But the important thing to remember is that then when you need to do the serialization, you need to pass essentially these JSON context. So now you may be wondering, okay, but why did they need to add a sort generator to this library? Well, the thing is that before this, the whole serialization process was being done with reflection. And the reflection was needed because in order to serialize a certain class, you need to know what properties are there, the type of the properties, and so on. So, but if you think about it, the properties that are the properties of an object are already known at compile time. So what you could even write the serialization yourself. So what the sort generator is doing essentially is going into your code, finding the JSON serializer context, and then finding the classes that need to be serialized, and then it's generating the whole serialization step at compile time. And as you know, reflection has some issues, especially if you're using, for example, ahead of time compilation. But in this case, the biggest probably advantage of using the sort generator approach compared to the reflection approach is that this is much faster. This is much more performant because this is already written at compile time. And according to the benchmarks from Microsoft, if I remember correctly, this is at least twice as fast as the reflection-based approach. So it's particularly useful if your application is heavily dependent on this. Now, so how do you see sort-generated code? Well, this really depends on your IDE. So, but for example, if you're using Visual Studio for Windows, then you can go into your Solution Explorer, into your dependencies, under Analyzers. That maybe it's a little bit confusing. Then you will see all your libraries that have an analyzer, and then under your library, you are able to see the sort generator and all the classes or the files that have been sort generated that have this beautiful yellow banner on top that lets you know that that essentially this file is read only because it's automatically generated. Okay, so now we talk about weaving, we talk about Realm, we talk about sort generators, we need to talk a little bit about Realm. So essentially, Realm is an object-oriented and cross-platform database that has been created, I would say, mostly with mobile in mind because it's not only available for mobile, and it's available for multiple programming languages like obviously .NET, Kotlin, Swift, TypeScript, and so on, and for multiple platforms. It has a lot of nice features, including device sync that allows to synchronize objects between multiple devices and with Atlas, so MongoDB in the cloud. But those are not very important. There are two features of Realm that are really important for this talk. So one of them is what I've already mentioned before, is that Realm is object-oriented. So when you're working with Realm, essentially you're working with native objects. So there is no ORM or any other translation layer involved. So you're working directly with native C# object in this case. And another feature that is important is the fact that Realm objects, and actually also collections, are live. The fact that Realm objects are live means that Realm object always reflects the data that is available in Realm at that time. When you have a Realm object and you get the value of a property, you're getting it from the database. If you're setting the value of a property, you're setting it into the database. So this is very different from what happens if, for example, you're using something based on SQL. Because in that case, when you get a value out of the database with a query, then this object is representing the state of that data when you did the query. It's not updated to what happened in the database. Okay. So now we need to see the way that we're using these two techniques. So in the beginning with Realm, we were using only weaving. And the way that we're using weaving essentially was for the model definition. So what you see on the left here in the define model part is essentially the way that developers could write a Realm class, so a model for the database. It's a simple class, so you just define your class, you define your properties with getters and setters, and then the important thing is that the class needed to derive from this Realm object base class. So in the beginning, we're using isle weaving because what we're doing, with weaving, we were going into the user code, in the isle code, sorry, we'll find all these classes, and then we will change the getters and setter with the getters and setters, so that they will call, like you see on the right, get value and set value. I'm not going too much into details here, but what get value and set value are doing essentially is getting the value directly from the database and setting the value directly in the database. And just to give you an idea, this is an extremely simplified version of what is happening, because actually it's much more complicated than this, because it depends on the state of the object, the type of the properties, and so on. So now, why did we need to do this? Why do we decide to do this? Well, essentially, we wanted to give the best experience for developers, and we want them to use just native C# object without needing to worry about the complexity of Realm or what's happening underneath. So essentially, weaving allowed us to hide a lot of the complexity of the Realm SDK and what needs to happen behind the model definition. So it was extremely useful for us because developers just use C# object without needing to worry about nothing else. Okay, so just to give you an idea about how the code looks like. So on the left, you have the IO code of the model as the user will define it. And then on the right, you have the IO code that is how it's been modified with weaving. As you can see, it gets much more complicated. You don't need to understand what is happening, just to give you an idea. So as I said, isle weaving is an extremely powerful technique because it allowed us to hide a lot of complexity behind the model definition, but it has some major drawbacks. First of all, it's not really readable. I mean, as you can see, the IL code is not really easy to understand because if you don't have experience with that. And for this reason, it's also quite difficult to extend because you need a very specific knowledge to work on it. And for example, on the left here on the screen, I'm showing part of the code that is responsible for the weaving. And if you just look at it, it's very difficult to understand what is exactly happening. Then it's a black box. It's a black box because essentially the changes to IL code are not visible to the final user. I mean, you can use a decompiler, yes, but it's not something that is very common. And finally, it's not debuggable because it's not possible to step into the weave code because the debugger doesn't have anywhere to jump to, essentially. Okay, so these are some of the reasons that made us move to search generator, the future. And so we had also to slightly modify the model definition. So on the left, you have the, let's say, classic model, the one with weaving, with your class, with the properties, and then derived from the base class RAM object. With the new approach, with the search generator, instead, the property definition is the same. What changes is that the class needs to be defined as partial, and then instead of using a base class, we are using an interface called iRealm object. The main idea here is that the search generator finds all these classes that are implementing this interface or declare this implementing this interface, sorry, and then it essentially creates new files with the rest of the declaration of the class, because the class is defined as partial, so it can be declared in multiple files. And so practically for the final user, the effect is the same because the class works exactly in the same way as before. And the transition from one approach to the other, it's very easy because you just need to add this partial class and then you need to add the interface instead of the base class. Just to give you an idea, this is part of the code that is being actually generated from a simple class. This is actually much longer than this. And you don't need to look too much at it just to give an idea. So the effect for the developer is the same, but because they can use the library in almost the same way. But for us, it has a lot of advantages actually. First of all, source generators are readable because essentially you're generating just plain C# code instead of some other kind of assembly code. And it's also debuggable because there is source code that the debugger can jump to. So they're very easy to work with because the generated code is just plain code. And for this reason, they're also much more extensible than weavers. And so these allow us to introduce new features for the model definition much easier. And another advantage is the fact that they are part of the compilation pipeline. So they're integrated in the build system itself, and they are less brittle. There are obviously also some issues with the source generator. So you're working with text generation, and if you want the code to look nice, so that developers, for example, can look at it, you need to spend some time making it look good. There are also some issues with performance because source generators can run multiple times, even with no changes. But this is something that has been addressed over time. And the biggest problem is that source generators are only additive. They can only add code, they cannot modify the existing code. And this also means that actually we didn't completely remove aisle weaving. We couldn't. And this is because if you look at the model definition here on the left, this is the model definition that you had with weaving, so with the base realm object class. Now, in this model definition, the user already defines the properties. So if we had to, and we couldn't simply go and modify them with source generators because source generators can only add new things, they cannot change what's already there. So what the user will need to do with source generators, for example, is what is here in the middle column. So they will define, instead of the properties, they will define some fields. And then we could go find these fields and then generate properties with the same name. Now, we decided not to go for this approach because essentially this is quite ugly. And I mean, it's quite ugly because you have these fields that are in your code that you shouldn't use, you cannot use, are not doing anything, and they're essentially just a blueprint. Another thing is that essentially the conversion from the previous approach to the new approach will be much more cumbersome. And so we decided to go against this because this is not giving the best developer experience. So we decided for the approach that you see on the right, that I've shown you before, in which we keep the property definition as before, but the class needs to be defined as partial, and we're using an interface. Now, the class, so the thing is that we're still using weaving in this case, and the way that we're using is still modifying the setters and getters of the property. So as you can see here, what we're doing with the setters and getters is that now the getters and setters are getting and setting the property with the same name on the accessor. That is something that we are source generating. I know that this looks very much like what I showed in the beginning with the weaver, so how the code looked like with 100% weaving. But I have to say that this is 100% of what is happening now with weaving. And instead, what I showed in the beginning was an extremely simplified version. So the important thing here to understand is that essentially we practically moved all the complexity from the weaver to this accessor. That is something that we're source generating. So it's much easier to do this because this is the same for each property. It doesn't depend on the state of the object and so on. So this is much easier to do. And so we reduce the weaving to the minimum that we can do, keeping the same developer experience. Okay, so we worked on the switch from weaving to, let's say, mostly source generation for about 6 months, and we published our first version of the source generator in November 2022. So now it's 1 year ago. We didn't, and so far we didn't get any major complaint, let's say. So we still support the classic model definition with weaving, and but we're pushing for developers for use the source generated classes, because at some point we will like to get rid of the previous model definition. And the fact that we moved to source generation also allowed us to add support, for example, for the nullability in the model definition. That is something that we wanted to do for a long time. We're also planning to add support for incremental generator that are, let's say, a performance-aware source generator. We didn't do it so far because we didn't get any complaints about performance so far. So, but we're still planning to do it because it should be more performant. So we also would love to love to do complete remove IL weaving. But as I said before, this is not something that we can do if we want to keep the same developer experience. We could be able to do it if C# will support pair sharp properties, because so we could go and modify the implementation of the getters and setters. And this is something that is getting more and more tractions, especially since source generators have been introduced, but we need to wait. So to sum everything up, code generation is an extremely powerful technique that we use in the .NET SDK of Realm to add a lot of complexity between the model definition. In the beginning, we're doing this code generation with IL weaving that is very powerful, but also difficult to use. And for this reason, we decided to move to source generators, or at least to a mostly source generator approach that are a much modern alternative and much easier to use. They have their own quirks and limitation, but overall, we think that the switch was worth it, and also our developers seems to appreciate it. So we are really happy about it. So thanks. That's what I had to say, and thanks a lot for your time. And if you have more curiosity about anything of what I've said about Realm, about weaving or generators, these are some resources. So thanks a lot.
Hi.
Hello.
Oh, thanks. Sorry. I think I think some platform I need to ask you some question. Some people love your session, but they ask me they want to know to use some resource to introduce intermediate language because they want to find this resource.
They want, sorry, what did you say?
Intermediate language.
Yes.
They want to learn more about this.
Yes.
Can you suggest some resource to them?
So I would say the major library that is useful for this is probably FODI. If you look online, it's probably the de facto standard for IL weaving. So if you look at something about FODI, you will learn more about it. Unfortunately, I would say this is a small part of our source code, so we ourselves don't have much experience about it. So most of the time when we had to work with it, we just had to look at how the IL code looks like in the model definition, what we want to look like after compilation, and then we need to figure out how to change the instructions. So it's not a very clever process, probably, but it's such a small part that we didn't spend too much time on it, I would say.
Okay. Another question is here. Can you see that? Question is, does the intercept can help in this evolution of Vim use?
So we think that it could, but this is something that we still need to investigate properly. We didn't spend much time on it. Also because, I mean, we need to support a lot of different .NET versions, a lot of different language versions. So this is something extremely new. So I think it will take some time before it gets into our library.
Okay, thank you. Thank you. Give
Thank you.
some good answer, good session. See you next time. Bye bye.
Thank you. Bye.